We spend a lot of time on this program discussing the ongoing controversy, the ongoing inquiries around the origin of the pandemic. And central to the question of how this pandemic started is gain-of-function research. On the one hand, you have scientists who've said that the evidence that has emerged thus far suggests that the research being done at the WIV, a lab in Wuhan, China, may have been responsible for the sparking of the pandemic. On the other hand, you have scientists who say that that is unlikely and that the evidence points to more of a natural origin. So today, rather than discuss that particular controversy, we want to get more to the question of what actually is gain-of-function research and what are the costs and the benefits of it to society. So we're bringing on two people who are both experts in this field.
Right, they know the subject better than we do, and we're joined today by biologist and assistant professor at MIT Media Lab, Kevin Esvelt, and immunologist and associate professor, Gigi Gronvall at Johns Hopkins University. They are joining us now to discuss. Welcome to both of you.
Thank you, happy to be here.
Pleasure.
So Gigi, I want to start with you. Could you tell us a little bit about what gain-of-function research is? I'm sure the audience is familiar with the basics, but from an expert, just define gain-of-function and then maybe tell us what you think people get wrong when they think of gain-of-function research.
Yeah, so gain-of-function research, that term came about when describing some influenza studies, and it's not like any function has been as important here. We're talking about the gain of transmissibility and pathogenicity. So those are the two functions that a pathogen might have that we would care about. It's a policy term because it's not something, if you're a scientist, you're not going to say, well, I'm doing gain of function research. It doesn't come from the scientific community. And so for that reason, it's a little bit hard to kind of retrofit it onto work that scientists are doing. But, people do work with viruses to better understand pathogenicity and to better understand transmissibility. And some of those experiments have biosafety considerations that you need to do them in high containment. You need to do this work in safe conditions. You need trained people to do it. And so, there is more oversight for that type of research. So I think it kind of gets all jumbled together, but for the purposes going forward, we're interested in how do we best understand? Is it important to do this kind of work? I would say it is important to do this kind of work to better understand the viruses that we are going to face as we deal with more pandemics, because it's not, COVID is unfortunately not going to be the last pandemic that we're going to face.
And Kevin, I'm curious for your response to that because I've just personally been kind of skeptical as I've learned more about this type of research, that there are actually the benefits that outweigh the serious costs, and the costs being the risks of sparking a pandemic, rather than actually finding ways to treat one or end one or slow one down. So where do you come down on the risk-benefit analysis here?
Well, I'm somewhat unusual in that I'm probably most concerned about the risk of deliberate misuse. That is, today, we don't actually know of any credible viruses that would cause a new pandemic. So gain-of-function research on potential pandemic viruses, trying to make them more transmissible, is one way that we might learn about a virus that could cause a new pandemic. And around 30,000 people have the technical skills to assemble an infectious influenza virus, since Gigi mentioned it, from synthetic DNA, which is readily available. And we know from COVID that a pandemic can kill more than 10 million people, more than any single nuclear weapon. So getting this right is really important. And I think something that gets missed is everyone here wants to save the most lives. We just disagree on how to do that. So I think we need to put some numbers on it. I think that's what's missing. Let's just assume that we can perfectly prevent any natural virus from spilling over from animals if we know what it is. On the flip side, once we know what it is, all those people can deliberately make it. So is that a trade-off that we're willing to make?
Gigi, what is your response to that? Where do you come down on the question of whether that's a trade-off we should be willing to make? And I'll add to it, gain of function isn't the only way to create a bioweapon. And there are many ways to create bioweapons that are now going to be sort of hard for governments, certainly, to control. So with that in mind, how do you fall on the cost-benefit analysis here?
Sure. Yeah, you're absolutely right about bioweapons. The bioweapons of yore, the ones that we know that Russia, for example, stockpiled, those would still be effective weapons. And those are the big concerns that we still kind of have about Ukraine, because Russia hasn't been investing in their biotechnology for a long time, but all that stuff is still within their grasp. I think we don't know as much as we really need to about when it comes to infectious viruses and the potential for spillover. And my favorite example for that is Omicron. When Omicron first emerged on the scene, we had everybody was like, "Oh, wow, that's really different than the previous version, and that's bad." And although they had more things to say, there was still a big gap in what we could say was going on with that virus, except until we could see it infecting people and then what happened to them. So we can't really look at a virus yet and say, and have a good idea of how it's going to affect a person. And I think that there is more that we can learn for that in that direction, and that would be useful. And I hope that in 20 years or so, we'll look back and say, wow, they really were in the dark about some of these variants, and they should have been really concerned about this one and not that one for these reasons. I think there's a lot more that we should be learning because we're just going to keep getting faced with them.
And Kevin, what though would we do with that information? Like what? In other words, what's the point of learning this stuff?
Yeah.
So there's really two rationales given. Number one, maybe if we know which viruses are dangerous, we could prevent them from spilling over from animals into people. Number two.
But how? Let me just stop you there. How are you going to? Okay, let's say you find it. You're like, uh-oh. This bat cave or this pig farm has this virus that we have now isolated and shared the recipe with 30,000 people, which is scary enough. But okay, we know that it exists here. What then? Slaughter everything at the farm, or like annihilate the cave, or is that the thinking?
Well, there's a lot of different proposals on the table, but I'd rather take a step back since you mentioned cost-benefit analysis.
Sure.
Let's just assume it works perfectly. So not even worry about vaccines.
Okay.
Obviously, it's hard to test a vaccine for a virus that you think might cause a pandemic, is of unknown lethality, and has never infected a human before. You'd have to deliberately infect people with viruses like that in order to test a vaccine candidate. So we're not going to do that. But let's just assume if we identify a pandemic-capable virus from nature, that we can perfectly prevent it from spilling over. And let's say if it had spilled over, these viruses would cause 10 million deaths, judging at COVID. But most viruses in nature will never spill over. That is, estimates of how many viruses out there can infect people range from 10,000 to 500,000. And we know that there's only 4 or so pandemics per century, just looking at history. So if there's 400 viruses out there that could cause a new pandemic of that magnitude, there's only a 1 in 100 chance that the one that we identify would have spilled over anyway. That would still means it would save 100,000 lives, which is a lot. But on the flip side, say there's just a 1% chance every year that one of those people would deliberately release it and cause 10 million deaths. Over the course of a century, that means it's likely to happen. And so the cost then would be 10 million lives. 100,000 lives saved versus 10 million lives lost. And that's assuming no accident risk, and that's assuming that knowing what it is would let us perfectly prevent it from causing any harm through the natural route. The numbers just don't add up.
Right, I want to get your response to that, Gigi, because that's persuasive to me, but I'm also wondering then on the other side, if what are we missing if we have all of these safeguards in place and basically bans against gain-of-function research? That might be a good way to frame the question. What would we lose in that case?
Yeah, well, so I just wanted to address a previous, discussion about culling. I mean, those are real world consequences if there's a virus that's particularly dangerous. This is the kind of struggle that we have with H5N1, with an influenza virus. So if it's detected in a bird population on a farm, I mean, yes, culling is exactly what happens, and these are real consequences for farmers and people who have livestock. And these decisions cannot be made lightly, and they're done in the public health interest. So it's important stuff. As far as I think we still need a little bit of humility as far as what we do know. We have seen great demonstrations of spillovers from the natural world, but that is something that we need to study better and make the case that we need to create more buffers between us and the natural world. Like, there needs to be maybe parks that are put in between where land is developed and where we have, bat populations and things like that. We need to study this much more. As far as what we lose the ability to learn more about the viruses, what's dangerous and what damage they're causing. I teach a class on 1918 flu. When that whipped through the world, we did not even know what viruses were. And so there was no potential for vaccines. So the virus wasn't even identified for 14 years. I think we don't want that kind of ignorance to be the way that we approach problems today. And I feel like, in 20 years, 50 years, people are going to look back at our scientific awareness, I hope, and think that we are just as ignorant as we look back at the world at 1918. And there are, yes, there may be problems that we have to deal with, but there are people who are losing their lives to infectious diseases every day. And we need to do what we can to better understand them and to prevent that from happening. So, and to develop better vaccines, better surveillance, better public health. These are all things that are happening today. And I appreciate the future concerns, and we need to be able to do what we can to address them. But there's some real world problems that we have to deal with in the next 2 or 3 years.
Yeah, and Kevin, you briefly mentioned, you said, let's assume that all of the spillover is prevented and that all of the biohazard risks, biosafety risks are handled 100% efficiently, that there are no accidents. So setting aside the deliberate release, there's no accidental release. But what is, in the field itself, what is the success rate when it comes to these types of biosafety measures?
So here is where I'm going to get lots of my colleagues angry at me no matter what I say. The answer is lab leaks do happen. They happen at a low rate. They happen at a lower rate, the better the biosafety level is. The risk is non-trivial. It's definitely not zero, like my cost-benefit calculation assumed. I think some experiments that are informative, that would answer many or even perhaps all of the questions Gigi addresses, could be done safely. And the number one way to do that is just never make a replication competent virus that you think might cause a pandemic in humans. Don't work with candidates in the laboratory that might cause pandemics in humans. But to address the misuse risk, the fundamental question is, do you need to learn whether a specific virus could cause a pandemic? Do you need to run experiments that can increase our confidence that it can, or not? Because you can sample the viruses out there, sequence them, ideally don't share the whole genome, leave a little bit out, but enough to let us test broad spectrum vaccines, broad spectrum antivirals, know a little bit more about which animal reservoirs, as Gigi mentioned, might be riskiest. That could then guide those efforts, tell us when to do culling. I think we can learn pretty much everything that would allow us to make better vaccines, antivirals, and prevent spillover without ever running experiments that would tell us, could this one be used as a weapon?
Gigi, do you think that's a reasonable solution?
It's hard to say. I mean, often the devil's in the details. And so for flu, if you talk to flu biologists or coronavirus researchers, it gets very hard to translate out what they're, the kinds of experiments they want to do. But I do agree. I mean, I strongly believe that things can be done safely. And I am not particularly worried about some well-resourced labs that take training seriously, that have funding for equipment and so forth. And a lot of the work that I am doing and I'm advocating for is to make sure that we kind of make that international, that we do what we can to support laboratories in other countries, that they have the resources they need to be able to do work safely. Because you can't, given how accessible biological research is and how nations want to fund their own research programs because they see an economic benefit from this, we need to promote biosafety norms in a more indirect way than, there's not going to be some grand authority that's going to tell a sovereign nation what they can or cannot do in some small biotech industry. So we need to do what we can to use all the levers to increase biosafety awareness and education.
Gigi, let me press on Kevin's point there. If it is the case that we can learn everything we need to know in order to, produce the best antivirals, produce the vaccines that map up against the potential threats that we have coming, why is it that these coronavirus researchers, these flu researchers, are still set on making these viruses that could replicate into a pandemic? Is it it's knowledge pursuit of knowledge? Is it DARPA and the defense industries, not just in the US, but in other countries, are willing to fund that kind of research, and so therefore that they'll do that kind of research? Why? And should it be left up to them? Because their opinion on this is interesting, but it should not, to me, it should not be the deciding voice. The research that they are doing affects everyone on the planet if they screw up.
Yeah, I mean, I think, well, clearly these virologists disagree with Kevin on this point, and I agree with you that it should not be just a matter of whatever somebody wants to do that they should be able to do. There should be oversight and discussion, and people should be doing what they are doing for a purpose. But often when you get into these details, some of the it's not quite as dangerous as maybe it's billed to others. And so, yeah, I think these things need to undergo review, technical review, extremely technical review, that they are taking the precautions that they need to take and that they are doing it for solid reasons. But it's really hard to do science in a hypothetical. And to have this kind of review that you're doing things for good purposes, that you're taking the precautions you can take, it gets into a very involved technical discussion, which doesn't make for as good TV, but it's really important. And I wish that some of our lawmakers had a much more nuanced understanding of biology, even if it is boring, to be able to have these conversations. And I feel like when it comes to the nuclear world, you have senators and congressmen who have a good understanding of this, even if they're not technical experts themselves. And I don't see that as much with biology.
Kevin, do you have any final thoughts or response to that?
Yeah, well, overall, the reality is the analogy to nuclear is a good one. If these gain-of-function researchers are successful in generating more transmissible variants of existing highly lethal influenza viruses, say, although this applies to coronaviruses as well, then they will have identified a combination of mutations in a virus or in a pre-existing virus in nature that could be released to cause a pandemic with all the attendant tragedy, causing more death and destruction than a nuclear weapon. And there is no way that they can succeed, that they can get any of the benefits. The whole point of their experiments is to learn which viruses could cause pandemics, even which viruses might or might not evolve to become pandemic capable. They cannot succeed without warning the world that this virus is pandemic capable. And I gave them everything in my cost-benefit analysis. And it still says one pandemic virus identified might save 100,000 lives, but the cost and deliberate release would be an expected 10 million deaths. Are we willing to publish the blueprints for what amounts to an arsenal of plagues when we can get almost all of the benefits without ever learning which particular viruses could cause pandemics? I would love to see a pandemic test ban treaty, because there's a narrow set of experiments that could cause pandemics. And I think we should ban those, because these things are more dangerous than nuclear weapons, and they are far, far more accessible. And I haven't even gotten into all of the ways that one could cause even more damage deliberately by releasing it in, say, a travel hub than it would cause naturally, which gives us more time to prepare.
This is a really helpful debate and conversation. Thank you to both of you.
Yeah, I think, Gigi, you made the best case you could, but I think this one's pretty clear, I think. What do you think?
Ryan voted.
Let's call the jury in here.
I think it's hard. It's hard. I think I'm probably still closer to Kevin's side on this, but I do like the 1918 example that Gigi provides is a really good one, because the advancement of information has helped us in sort of incalculable ways. It's hard to quantify.
I'm for the pandemic test ban treaty. I'm all for that. Thank you guys for joining us. That was really helpful.
Thank you.
And we'll have more Rising right after this.